Okay, we are recording. So before we get into today's lesson, I just mentioned off camera that I'm going to talk about the test. So the test covers chapters 1 through 4. So this is the last material. Today's that will be on the test. Test opens at 5 a.m. on Tuesday, and it closes at Thursday at midnight. Normally, I would have given you the practice test yesterday, but I'm having some major technical difficulties. I was trying to switch to proctoring using Respondus, which requires a lockdown browser, but for some reason, none of my 3 computers will connect to the college, their intranet in order to download what I need to download in order to connect Respondus to Blackboard. So we are going to be using Proctorio. And I will be, after this class is over, I will send out the practice test. All the practice test does is make sure that the proctoring software works. The questions on the practice test are not content. The only math on there is, I think it says what's 2 plus 2. So if you can do 2 plus 2, you can do the practice test. There's no like content on it. It is just testing your ability to use the software. In order to use Proctorio, you need to use the Google Chrome browser, and there will be an extension that you need to add. And then it'll like right on your computer, you'll be able to take the test, and it will do the proctoring for us. I really wanted to use Respondus, but it just, until I can make it over to the college and use their computer, unfortunately, I can't do that. So it's going to have to wait till like this summer or something. So what was that?
I don't know if it has anything to do with what you're trying to do, but RCC did send out a notification today about some programs not responding. So I have no idea if it has anything to do with that. I can't remember exactly what was listed, but
yeah, I don't think it did, but I mean, that's a good point. And I mean, I could always try it again in the morning, but currently it looks like, well, Proctorio works just fine. I've never had a problem with it. I just know that after this term, Proctorio, we're not going to be using it anymore at the college. So I was going to try to switch over now, but it's worked well for me in the past. And so I think I'm just going to keep it for this term. That way we can just remain consistent. I would hate to have the first test be one thing and then switch to something else, the second test. Nobody needs that extra stress. Well, there's enough stress already. I mean, I teach math, I know. So, you may or may not have seen it. If you downloaded the syllabus and looked at the calendar, I don't have a regular class on Tuesday. What I always do the first day of the test is I am just on Zoom from 5:30 to 6:30. So that if you wanted to pop in for office hours and ask questions regarding the review or homework assignments or anything else, I'm just available. So you can just drop in between 5:30 and 6:30 on Tuesday, and I will be available for any kinds of questions, kind of an office hours type thing. And that will probably go out with the Sunday email that I normally send out. I will send that information out also. But so it will not be regular content on Tuesday, what date, 25th. It'll just be me here for office hours. And that'll be every time we have a test, the first one, the day the test opens, it's just an office hours class. So you can show up or not show up or take a nap or whatever. All right, any other test? I forgot. So the test is open notes, obviously open calculator. It is not open book, it is not open friend, and it is not open cell phone. So just use your calculator and any notes that you have paper copies of. So print out PowerPoints or whatever you write down or whatever. So feel free to use your notes. The reason I do that is because it is something, even with our proctoring software, it is something really hard to police. Since you're at home on your computer, it's really hard to police it. And most people would be honest and would just not use notes if it wasn't open notes. But there's always some people that wouldn't be. And I feel like in order to keep it fair, it just makes sense to make it open notes for everybody. So nobody has to, I don't have to worry about anybody being dishonest or anything. And it's just open notes for everyone. And that way it keeps it fair, if that makes sense. And besides, I mean, it works. If it works, why change it? Right. Any questions about the test before we move on?
Ms. Kleiss,
Yes.
I just want to verify and make sure you mean open notes and you said we can use the PDFs because I generate a binder and print everything off every week.
Yeah,
These are 100% usable.
they're 100% usable. They're your notes, even if you printed them off and it's what I wrote down. They belong to you now. You printed them off, right?
Okay, that's all I need to know. Thank you.
Yep, no problem. Good question. Any other
So the
questions?
test will be on Blackboard?
Yes. It is
Okay.
on Blackboard. It is on Blackboard. It's just proctored through Proctorio. So the extension goes on your Google Chrome and it will, I think it verifies. What it'll do is it'll like listen to your room first, be like, okay, so this is what the room sounds like regularly. If you like, and then it'll make sure it can see your face and then you'll barely even know it's there.
Okay, I've never done this before.
So there will be instructions. I'm sending out an email right after this class with instructions. And then
Okay,
the purpose of the practice test that I'm sending out is so that we catch any issues before you're taking the actual test. And the practice test gives you some extra credit. Everybody loves extra credit. So basically the practice test is just, it's a test run to make sure that when you take the regular test, you're not having issues. So we'll make sure that we help you out. And if it's something I can't help with, Proctorio does a really great job helping troubleshoot. So we'll try me helping you first. And if I can't figure it out, then Proctorio can also troubleshoot. They're really good. Their chat, they're excellent. So, okay. Anything?
okay.
Ms. Kleiss,
Yes.
just real quick, I already have Proctorio. I've had to use it for certain courses the last 3 terms.
Uh-huh.
Correct me if I'm wrong, but Proctorio is just a screen recorder, isn't it? It doesn't use a webcam or a microphone. It keeps you from using a dual screen setup.
No, it depends on how it's set up. Different teachers set it up different ways. Mine requires a webcam.
Okay,
I want to see your face. I want to make sure you're not on your phone or you're not talking to somebody else and things like that.
okay. I'll have to look into it on the extension because I don't remember seeing that there was a setting in there where you could have your webcam and microphone affiliated with Proctorio. I was under the impression it was just a screen recorder.
I believe that if the test requires it, I believe it asks your permission when you're starting the test. It'll ask your
Okay.
permission to allow it.
Okay,
Yeah, the test is due on Thursday at 11:59. So if you look at the test, I'm just going to go there. I'm just, I'm screen recording. I might as well just go there. So let's see, let me find it. So if you look at the test and syllabus page, I don't know if you've been there yet. Right here, I'm going to make it bigger. It shows the date that the test opens and the date the tests close. So all 3 tests are here and the final project dates. So all of that is on the tests and syllabus, tab over here. So all of that is right there. So if you need to look at any of these test dates, we have plans coming up and need to make arrangements, it's all right there. It just doesn't, until I actually make the test available, for some reason, it doesn't show up on your calendar, but it shows up. I don't know if it shows up. I don't remember what I wrote in the syllabus. I wrote it so long ago, I don't even remember. But that part right there, that's a really good resource. That's the word. All right.
I'm so sorry.
That's
One
okay.
more question. Is it timed?
Yes.
Okay.
The test is 90 minutes. You do have to show your work. This was a really good question because I forgot this piece. The test is going to be 90 minutes. Most people finish it in about 60. When it was originally written, it was written for 60 minutes. But because I require you to show your work, I gave an extra 30 minutes so that you can make them neat enough and not like writing chicken scratch so that I can't read it. So you need to show your work on a separate sheet of paper. After you are done with the test, once you submit the test, you have a half an hour to take a picture or scan it or whatever you want to do. And there will be an assignment underneath the test for you to upload your work. And you can upload as many pages as you need to. And the half hour is somewhat flexible, but if I've noticed that you uploaded it 6 hours later, I might be a little concerned, but just try to get it uploaded within about a half an hour of finishing the test. And there's always times when somebody has issues uploading it or whatever, and I'll try to help you if necessary, but just try not to start the test at 10:30 on Thursday night. Seriously, give yourself some time and realize the work uploading also closes at midnight. So you need to give yourself that half hour also, but things can go wrong. And if you're waiting till the last minute, I'm not going to be awake. I'm going to be sleeping and I'm not going to be able to help you. So trying to take it ahead of time is a really good idea. Putting it off to the last minute, going to stress everybody out. All right. Now
So when we start the test, we have to continue it within that hour and a half.
Yes.
We can't break up.
Nope, you cannot break it up. You got to, once you start it, you're
Okay.
one sitting.
Okay. And can we have somebody send it in to you? I'm terrible at doing that. So I usually have my daughter just send my stuff in.
You need to upload it it's uploaded into a My Open Math assignment.
Oh, okay.
Yeah,
All right.
kind of like your hand in homework. It's
Oh,
uploaded.
yeah, I have that too.
Yeah, it's uploaded basically the same way as your hand in homework.
But is it okay if I have her help me
I
do
mean,
that?
I'm
part?
not going to be able to tell one way or the other because you're not going to still be on
Okay.
camera. So I won't know one way or the other.
Okay.
Yeah.
It's just, I need help getting it into you. Is
Yeah.
all.
I get that.
Thanks.
That's fine. All right.
Okay.
We go now? We good? All right. So let's get to today's lesson. So I don't know why, but I really love linear regression. I really love it. Linear regression is one of the most interesting things I do. I use it for all sorts of things. And it's kind of fun to see how things are correlated with each other. This is going to be a really strange thing, but I'm going to tell you guys a linear regression story. When I was in college, we had a lot of downtime. I worked in the tutoring center and we had a lot of downtime. So we had this conversation one day about how old is too old to date. So how old at the age you are, how old is too old to date to the point that it would be creepy to date that age? I know this is a weird conversation, but a bunch of kids in a tutoring center is what we talked about. So we went around campus and we started asking questions to people. So at your age, how old is too old of a person to date? Or how old is too young to date? And so we just got all of this data and we ran a linear regression and we were able to create an equation so that we could calculate at any age what their dating range could be. It was just the funniest thing. We used linear regression for that. And not that that's super useful. It was just funny. But you can make predictions based on, you collect a little bit of data and you can make some predictions based on the correlation and how strong that relationship is. And I'm going to show you a really fun website at the end of this that you probably get a kick out of. So
For gas and timber?
So we're going to talk about scatter diagrams. We're going to talk about linear correlation coefficients. We're going to talk about linear relations and whether or not they exist and look at the difference between correlation and causation, then get a least squared regression line. So I know all of this stuff is foreign language to you, but it won't be for long. So let's get going. It's okay if you didn't understand any of those words. We're gonna get you understanding them. Okay. So you may remember back from probably Math 60, talking about independent and dependent variables when discussing X and Y, because most of your equations where Y equals a MX plus B, we're basically defining Y with X, saying, okay, if X is this, then Y is this. So Y would be your dependent variable and X would be your independent variable. So in stats, we have a response variable. That is what we call our dependent variable. because in stats, we can't just use the terms that already exist. We have to create all new terms because that's what we do. So the response variable is the dependent variable. It is the variable that we can explain in terms of the other one. The explanatory or predictor variable is the independent variable. So this provides information about the dependent variable. So for example, like we're thinking of miles per hour, we don't go any miles unless time passes. So time would be our explanatory variable because time is the thing that causes us to move, to travel a distance. If time doesn't pass, we don't travel. So as time passes, we travel a certain distance. The distance we travel depends on time. So time, distance would be our response variable. Time would be our explanatory variable. If that doesn't make sense, it's okay. We'll be good. A scatter diagram. So a graph, it's a graph that shows a relationship between two quantitative variables. You've probably seen this before, and scatter plot is another word for it. And basically, so each data value is on the same individual. So for example, if I was looking at number of cups of coffee per day and how many hours they sleep at night, one person would be one dot. We would line up how much sleep they get with how much coffee they drink, and that would be one dot. So every dot is one individual that we have two different characteristics we're measuring. All right, let's move on. So here's our first data. The data shown to the right are based on a study for drilling rock. We're trying to determine, or the researcher was trying to determine how much time it takes to drill 5 feet, depending on how deep we begin drilling. And I'm sure it depends on, it has to do with the density of the rock or whatever that's down there. So like, for example, if we start digging or drilling at 50 feet down, it took me almost 6 minutes to drill 5 feet. We start drilling at 190 feet down. It takes about almost 8 minutes, to drill 5 feet. So our explanatory variable, our explanatory variable is the depth at which we begin drilling. And then our response to that would be how much time it takes to drill. Because if we don't start drilling, it's not gonna take time to drill because we didn't start drilling. So this would be this is our explanatory, and I just did that. Okay, this is our explanatory. And I think it says it in the words, but this helps. This is our response. So whichever one causes the other one to happen is our explanatory. All right. What does it tell me to do? Oh, we're going to draw a scatter diagram, or it's going to be drawn for us on the next page. I'll give you a second. All right. So this is our scatter diagram. So we just plotted all the points. So some things to kind of notice about our scatter diagram is you can kind of see a trend. You can kind of see that as we start drilling at a deeper, it takes longer for us to drill. If I drew a line like through the middle of all of these, that was a really bad line. They're supposed to be half above and half below. So let's just pretend you can see that it definitely has like this positive slope there, right? So if you're thinking about what slope of a line is, it's definitely got a positive slope. We're going to erase that because it's a really bad line. But I just want you to kind of notice that it's kind of trending upward from left to right. This is just a beautiful scatter diagram. We're going to draw one of our own here in a minute. This is going to be in a second here. So this is a whole lot of words. So we have a golf pro. He wants to look at the relationship of the speed of his club head and the distance the ball travels. There's other variables, so he doesn't want any of the other variables to affect his outcome. And so he's making sure using the same model of golf club, the same ball, it's the same golfer. It's a beautiful 70-degree day. There's no wind. Everything is the same in every trial. Every time he tries it, it's going to be the same. Everything's going to be the same as much as possible. And we're going to collect some data. Here we go. Here's our data. I'm going to use a different color because I want red. So our club head speed is our explanatory variable, because if we don't, the club head doesn't move, then the ball doesn't go anywhere. So this is our explanatory. And this is our response, because in order for the ball to move, it has to respond to that club head. So you plot these points just like you're plotting points on a coordinate grid, because this is just a coordinate grid. So at 100, 257, we just got to kind of guess where they are. Let me see here, about here. At 102, I'm just going to draw all of these lines here. 103. Don't worry, you're not, I don't believe you're going to ever have to do this by hand again, just this one time. And even in hand and homework. And I'm working on the hand and homework, by the way. About a third of the way done. We have a lot of students in our class. I'm working my way through them, and I'm making sure to leave feedback. If I deduct points, I will leave feedback. So I'm working on it. If you don't have a score yet, it is because I have not graded yours yet. If it shows as a 0, I just haven't graded it yet. I'm working my way through. All right, there's my scatter diagram. Once again, you can kind of see that that has the upward trend. I mean, it kind of makes sense. If the club head is moving faster, the ball is probably going to go further. So that kind of makes sense. You can kind of see that upward trend. So that's really it. That's our scatter diagram. Any questions? Okay, we're gonna add some things to this and make it more fun, because more math equals more fun. At least for me, it does. You need another second? Okay, we're gonna move on. Move on. All right. So let's talk about different types of relations. So we are only dealing with linear relations in this class. If you go on to Math 244, which very few people do, you basically need to be a math major, or I mean, there's very few majors that require Math 244. If you go on to 244, you might be doing other types of relations. We are only worrying about linear. So take a look at the top two up here. Both of these look pretty linear. I could draw a line through them and get a nice line. They follow a linear pattern, and they both have linear relation. This one is a positive because it has a positive slope. And this one is negative because it has a negative slope. But they're both linear. So down at the bottom, so they don't have a linear relation, but they still have a relation. So this one right here, you may recall if you've taken, what is it, Math 65, this looks quadratic, but it's definitely not linear. This one right here, I don't know which math class, I don't remember which one we deal with this, but this one is basically cubic. You don't have to know that. This is just me saying it because I'm saying it. So it has a relation, it just isn't linear. So make sure that if you are answering a question regarding the relation, you would just say it has no linear relation. You wouldn't say no relation. You would say no linear relation, because it's not linear, but it could have some other kind of relation. This one is super scattered. It doesn't have any relation at all. It is just scattered all over the place. But even if you still just say no linear relation, you're still fine. Questions? Whew. All right, I will move on unless anyone tells me to stop. Positive association. If they're positively associated, as one variable increases, so does the other. I usually just think of, does it have a positive slope? If I was to draw a line through the center of the data, would it have a positive slope? That's a positive association. It looks something like that. Has a positive slope if I drew a line through it. So that's a positive association. Negative association, as one variable goes up, the other one goes down. It doesn't matter which is which. As one goes up, the other one goes down, or it has a negative slope. I like to think of it as slope because that's easier for me to remember rather than looking at, okay, this one's going up and this one's going down. Just look at the slope. If it has a downward from left to right, then it is negative association. Questions? I'll give you a second. Oh, and I forgot to say we are doing lab 3 today at the end. Forgot to say that in the beginning. We will be doing lab 3. Lab 3 is kind of fun. I like lab 3. I say that about everything, don't I? Okay. I will never make you do this by hand. Never, ever, ever. So don't get scared. I will never make you do this by hand. I do make my AP stats kids at the high school do this by hand, but I'm not going to do that to y'all. Would not do that. So be thankful. It's not that hard. It's just a lot of work. It's a lot more work than standard deviation. So the linear correlation coefficient, it tells us how strong and in what direction our relation is. So if it's a super strong positive linear relation, I'm going to have a higher positive number for my linear correlation coefficient. If it's a super strong negative correlation, I'm going to have a larger or a more negative correlation coefficient. So if we are dealing with a population correlation, we would use, rho. We will not be using rho in this class. The reason is you don't need to run a correlation, a linear correlation regression if you know the population. If you know the whole population, it is pointless to write an equation that makes a prediction. So we don't do that. We're just going to use R. R is for our sample. It's a sample correlation coefficient. And so we'll just be using R. And most of the time we just call it an R value, but it is the correlation coefficient. It's just R value is easier and quicker to say. And it's also a lot easier to write. I would like to write R value much more than correlation coefficient. Besides, most people can spell R value, and you'd have to sit there and sound it out as you spell it for a correlation coefficient. At least I would. I mean, I'm a good speller, but sometimes. Okay, so this, this is, yeah, basically what's happening here is you're calculating all of the Z-scores of the X values and the Y values, and you're multiplying them together, and then you add them together. And then you divide by 1 minus the number of values you have, but we're not going to do that. I'm moving on. I'm going to get this ugly thing away from us. Now there's going to be a whole lot of words on this page, but there's a whole lot of words. I don't know why they do this. So linear correlation coefficient always between -1 and 1, and both -1 and 1 are allowed. So -1 is a perfect negative linear relation, and a +1 is a perfect positive linear relation. I just said that. I just said that too. Imagine that. So the closer we are to 1 or -1, the closer we are to a perfect linear relation. So +1, it's strong positive association, -1, strong negative association. And the closer we get to either one, the closer we are to a perfect linear relation. Give you a second. Okay. If we are close to 0, there's little or no evidence of a linear relation between the two variables. So basically, if we're right at 0, then there's no linear relation, or but it doesn't mean that there's no relation. Because something like a beautiful quadratic, which that's not beautiful, but it's kind of quadratic, that would be, it would have a 0 for your correlation coefficient, but it's still a relation. It's just not linear. And it's unitless, so we don't say 0.99 potatoes. We don't apply any units to it. It's just 0.99 or whatever. It's non-resistant. What this means is that any outliers are going to change my R value drastically. It means that it cannot resist an outlier. It is pulled towards the outlier because it can't resist it. Kind of like me and cheesecake. All right. See, I told you that was a lot of words for not very much stuff. Okay, here's examples. Letter A, perfect positive linear relation. B is pretty strong. It's a 0.9. My R value is 0.9. It is pretty strong. Letter C, I don't agree that that's 0.4. In my opinion, it looks like a 0.6, but I still would call it moderate. And then D is a perfect negative. And once again, I think this probably is a negative 0.6. Both the last two are close to 0. They don't have any linear relation. So when it comes to saying whether you have strong, moderate, weak, all of that, there's not a hard and fast rule. And I really hate that. And most people hate that there's not a hard and fast rule. It really depends on how much it matters that it's strong. And if I'm building a space shuttle, I want near perfect. If I'm putting a garden in my backyard, I don't care. So it depends on what you're looking at and how important it is. Here's my rule of thumb. I'm going to put it on another page. This is just my rule of thumb. So I am not going to get mad at you if you do it different than me. So I would say like moderately strong, or use an adverb in there. It's relatively strong is a good one. Relatively strong. Relatively strong could be like 0.85 to 0.9, or just say strong or strong. Or, all the way up to 1, because 1 is perfect. This is perfect. But anything probably between 0.85 and 1 is probably strong or relatively strong, depending on what words you want to use. So if I had, let's say, maybe 0.75 to 0.85, and I know I'm not writing this nicely, I could say moderately strong. I don't know if I've said it before, but statisticians don't deal in absolutes. We love our adverbs. So you're just going to always throw things like approximately, moderately, relatively, things like that. This is what we do. And if I had something like, let's say 0.45 to 7.75, I could just say moderate. Not moderately strong, but just moderate. Anything less than 0.45, I could say relatively weak. Weak to weak. So if it's like really close, like if it was a 0.2, I'd probably say weak. If it's 0.35, I could say relatively weak. If it is at 0, there's no relation. And this is the same thing with negatives, just the other direction. As I said, there's no hard and fast rule. If you had a 0.7 and you called it moderately strong, I am not marking you down for that. But if you had a 0.3 and you said moderately strong, I'd mark you down for it. So if you're way off, but it's all kind of a gray area. There's no hard and fast rule, as I said. Any questions on this?
I'm not sure if I caught what you just said. If you had a 0.3, that would be a what?
If you had a 0.3 and you called it strong, I'd probably mark you down for it.
Oh,
But if
gotcha.
you have a 0.7 and you said moderately strong, I'm not going to mark you down for that. It's just if you're way
Okay.
off. Or if you called like 0.9, if you called that week, I'm probably gonna mark you
Mhm.
down for it. So just be
Okay.
reasonable, just, there's a lot of gray area in the interpretation.
Okay.
And so I'm gonna be super lenient on it. Okay. Anyone need this still? I can give you a second. No, we're good. Okay. All right, let's go. Uh-oh. All right, we're gonna look at the linear correlation coefficient of our drilling data. I would like you to pull out your fancy schmancy calculator. Pull out your fancy schmancy calculator. So what we're going to do is we are going to put the X1, we're gonna put this right here and whoa, stop it. It's my own fault. I do it. I hit it with my hand in it. So we're gonna put this in L1 and we're gonna put this in L2. I'm gonna go to my calculator so you can just copy what I have in my calculator unless you have the PowerPoint in front of you. And I'll make it big so you can see it. Okay, let me move some stuff around here. Okay. I'm gonna make it big so you can see it, maybe. Hit my stat, edit. Okay. Remember, we do clear, not delete. Do not hit delete, hit clear and enter. Okay. I will put the values in here and you can copy me unless you have it printed. I have 190. Okay, I've got all of my. I'll give you a second to get the rest of those in there because I'm going to have to go over to L2 and start entering them in from the top. Because I know a few of you are using my computer screen. Okay. I'm going to go to the top now and enter the other ones. 5.88, 5.99. Sorry about my neighbor and the lawnmower. Hopefully it's not too much of a distraction. The whole working from home thing. 0.42, 7.97, 7.62. Well, I missed something I did. This is 7.92. As I said, most common errors typing it into your calculator wrong. 6.98. And then 7.9. The worst thing is when I get to the bottom of my second list and my lists are not the same length and I have to go find where I messed up. Give y'all a second to finish entering those in and then I will show you what to do. Okay. Make this smaller. Okay. Anyone need another moment? Are we good? All right, you're gonna hit the stat button. Now, once you have all of these in, hit the stat button and then arrow over to calc. We want number 4, linreg AX plus B. It's linear regression AX plus B. That's what we're looking for. Okay, my X list is L1. And it gets smaller here so that you can see where your X list is L1. I don't know if you remember me showing you how to put the lists in here. Your Y list is L2. So if you don't have that in there, you would hit second 2. Notice the little blue numbers on top of there. So you'd hit second 2 to get L2 in there, leave the frequency list blank. Leave the store reg EQ blank and just go down to calculate. And then hit enter. Okay. If anyone, I'm gonna, because somebody might be watching this video and might be having this issue. If anyone is missing the R squared and the R on theirs, I'm gonna show you how to get that. And even if nobody in here is missing it, somebody who's watching might be. So if yours just has the y equals ax plus b and the a and the b, then I'm gonna show you how to fix this. So down, notice above the 0, it says catalog. This is every program that your calculator has on it. So I'm going to hit second catalog. And then we're just going to arrow down for a little while. You can hum a little tune. You can, I don't know, tell somebody to clean up their mess or whatever you need to do. Go all the way down to D to diagnostic on. Where is it? Right down here, diagnostic on. When you get to diagnostic on, hit enter. And then hit enter again, and it will turn that diagnostic on. Then now when you go to stat, over to calc, down to your linreg, now you will have that R and R squared, or yeah. Okay. R squared is not anything we use in this class. We only use R. Our R value here is 0.785. Based on what I told you earlier, I would consider that a moderately strong correlation. That's how I would call it. If you called it moderate, I'd be okay with that. I usually call it moderately strong, just because, you know, adverbs and all that.
Ms. Kleiss,
Yes.
Okay,
I
that's not.
just
what
triple checked my numbers for L1 and L2 and verified they followed the chart perfectly.
And you got different number?
I ended up with a completely different answers for
I'm guessing, I put something in wrong. Let me check. 35, 50, 70, 125, 120, 130, 145, 155, 160, 175, 185, 190. Okay, let's see. I'm guessing
I think your 185 is supposed to be 6.89.
oh yeah. You guys are awesome. 6.89. Thank you. That's going to change everything. I'm going to look at the rest of them real quick here. See, I told you the biggest error is typos in the calculator. And I am notorious for that. 6.1, 7.47.
Tell me how you went back. 'Cause I copied you, so
You copied me?
I copied you. Oops.
Sorry. I led you astray. How terrible. I'm so terrible. Let's try this again, and we'll see what kind of a correlation coefficient I get now. That was just a test run. I was just testing to see if y'all are paying attention. Good job. Good job. All right. Is that better?
Now we're
Yeah,
good.
that's what I got.
Yep.
That's what I got.
Now
That's
we're
what I got.
cooking with gas. Awesome possum. Good. Sorry about that.
When I cover the number, when I cover, because I have at the 185, I have 6.9998. Sorry. Do I just press clear? I'm kind of scared to press clear.
No, if you just, can you just arrow up to, are you able to just arrow up and highlight 6.89?
Yeah.
Okay, then you should just be able to type right over it.
Okay. And it was 6.98. Or
6.89, yes. Should be- Yeah, and now you should just be able to hit enter and be fine.
Okay, perfect. Thank you.
I know it's scary when you're not used to it. It gets scary.
Yeah.
But I'm going to be showing you so many really cool things because I learn something new all the time. I can't believe how much these things can do. It's amazing. Okay. So this, our correlation coefficient, I still would call that moderately strong. I'm going to go back to the other screen. Where are we? Okay. I would call this moderately strong. And you can call it what you want to call it, but I mean, it's definitely not weak, but it's not super strong either. So you can throw your own adverbs in there because we all love a good adverb. See that there's the connection with the English and the math right there. So you should get English credit for this class because of all of the reading comprehension and, you know, use of adverbs. We should get some English credit here. Okay, moving on. All right. Now let's try the club head speed, but before you do that, if you don't want to, because we're probably going to access it again, are we? We might be, I think we might be accessing it again. I can't remember. You can use L3 and L4 for your club head speed. I want you to try putting those in here by yourself. Go use L3 and L4 for your club head speed. And then you can use that instead of L1 and L2 in your LinReg, you can do L3 and L4, and it'll just pull those data values. So I can show you. I'm going to go to the other screen and you can copy me, and I'm going to do it right this time. I promise. Well, no, I don't promise, but I'm convinced. So L3, I'm going to use my club head speed. At least there's fewer data values, and so I'm less likely to make a mistake. I'm going to make it bigger though. Ooh, that was really big. Okay. 101, 105, 99. Without decimals, I shouldn't be able to make as many mistakes. I said shouldn't. Mm, 258, 275. I'll give you a minute. Let you copy all my numbers. I'm gonna check them over while you're getting them in there. Are we good? You need another second? Good. All right, I'm gonna make this smaller so we can see the things I'm doing. Hopefully not messing with your eyes while you're looking at it. Okay, so now we'll hit stat, arrow over to calc, go down to your fourth one, and I'm going to change this to L3 and L4. So you do second 3, get smaller. So the L3 is second 3, and L4 is second 4. And so it's just going to pull those numbers instead. And I'm hoping that's right. David, you're going to tell me if I'm wrong, right? I'm counting on you.
Nope, we're good.
Okay. So we've got R equals 0.94. I just rounded to the nearest hundredth. So I think we all can agree that this is a pretty strong correlation. I think anything over 0.9, just use the word strong. It's a strong correlation. So one of the reasons that we need to know the strength of the correlation is because that's going to affect our ability to make predictions. So if I have a correlation coefficient of 0.3, I'm not going to be able to use the equation that I get to make any predictions at all. But if I have something super strong like this, 0.94, I probably can do some predicting on how far is the ball going to go. If, like, let's say my club head speed was 110, I probably can make that prediction and be somewhat accurate. So the stronger your correlation, the more accurate your prediction is going to be, if that makes sense. So we like strong and accurate or strong correlation coefficients. Any questions on this before we jump back to our PowerPoint? Okay, moving along. All right, here we are. This is strong. Okay, that really looks like it's a story, but yeah. Okay, let's move on to our next thing. So correlation versus causation. Okay, so this is so much fun, and I'm going to show you my fun website in a minute. So if our data is observational, so if it's not something that we've applied, like saying, here, try this medicine, and then we have our control group and all of that. If it's something we've observed, we can't assume causation. Correlation does not equal causation, even if it really looks like it does. You cannot state that something caused something else. Like, even if, I mean, it may look like it does, like with the drilling data, you can say, it looks like if I'm drilling deeper, it's causing me to take longer to drill, but we can't say that it's causing it. Plus, sometimes there's outside variables that we don't know about. So here's an example. The correlation between teenage birth rate and homicide rates since 1993 is 0.9987. However, you can't conclude that higher teenage birth rates cause a higher homicide rate because this data is observational. There are other factors to be considered here, and all you can say is, yeah, they're correlated. So as one thing goes up, the other thing goes up. So we can expect that to continue, but we can't say one thing causes the other. And I'm going to give you this website, show you this website because it's fun. And, you know, the more fun I can put in this class, the better. And I need to move my little bar. I have these weird bars up at the top that I need to move. Come on, move. Or not. Okay, there we go. I'm moving them out of the way. Give me a second. Okay. So there's this. Uh-oh. Tyler Vigen. Come on. Why isn't it letting me type? Rude. I don't know why it's not letting me type. I'm going to go to a different browser. It's still not letting me type. What is going on here? Okay. I don't know why it's not letting me type, so I guess I can't go there. What the heck? Did I hit something? I don't know if I did. Yeah, I don't know what's going on. So maybe I can't show you. I thought maybe that I hit a button or something, but here we go. Hold on. We're gonna go back to my iPad right here. I'm going to outsmart my computer. Here we go. So there's this website called Spurious Correlations. And what it does is it shows things that are correlated that really, I mean, you can't say that one thing causes the other, but they're really funny. Like, for example, right here, the US spending on science, space, and technology correlates with suicides by hanging, strangulation, and suffocation. There's a 0.9979 is the correlation coefficient. So films Nicolas Cage has appeared in, and the number of people who have drowned by falling into a pool. So apparently, if Nicolas Cage is in a movie, people are going to fall in their pool and die. It's moderate, though. It's 6.66. It's 0.666. Well, that's kind of scary. This one's funny.
Where does one find something like this? That's what I want to know.
TylerVigen.com. I'll write it down on the PowerPoint because you can create your own. You can choose things and how high of a correlation coefficient you want. And it's hilarious. It's so much fun. So this one is per capita cheese consumption correlates with number of people who died by becoming tangled in their bed sheets. 0.947 is my correlation coefficient. See, I told you math can be fun. Apparently, divorce rate and margarine consumption are correlated. So if you eat a lot of margarine, you might get divorced. 0.9926 is our correlation coefficient. It's just really hilarious. There's a ton of it. Arcades and computer science doctorates, mozzarella cheese consumption, and civil engineering doctorate. So if you want to have a doctorate in civil engineering, eat a lot of mozzarella cheese, because that's a 0.9586. So it's a really great website. He even has a book, and it's just hilarious. There's so many fun things. And yeah, this is like one of the reasons I love teaching chapter 4. I will write down the website for you just in case you want to take a look at it on your own. I outsmarted my computer, so that was good. TylerVigen.com. It's just Spurious Correlations is the name of the website. I'll write that down because if you want to just Google that. Because there's a link on there where you can choose things and create your own, and it actually will give you the actual correlation coefficient and a graph and everything. It's pretty fun. And I have no idea why it wouldn't let me type. I hope that doesn't affect my ability to do the lab. If it does, I'll just do it on my other computer. My computer's just being mean to me. All right, moving on. Okay, so there's this thing called lurking variables. So this is something, it's not included as an explanatory or a response variable, but it can make it look like something has a strong relationship, but it's actually like linked to both things, or it can hide a true relationship. Here's an example. As air conditioning bills increase, crime rates also increase. So turning off your air conditioner is not going to combat crime. So both things are affected by air temperature, and crime rates increase as air temperature increases because they're out there and they're not huddled under their blankets. They're out there committing crime. So we all know that crime rates seem to be higher, like during the summer and warm weather and things like that. So lurking variables are really a thing. All right, moving on. So the least squared regressions line. So we're going to be really happy we kept that data in our calculator, because we're going to be calculating least squared regression line. Once again, I will never make you do this by hand. There is a really big, ugly, actually a few really big, ugly equations that or formulas that you would need to use. I will never make you do it by hand. Excel does it beautifully. Just let Excel do its job, or your calculator. Let them do their job. So this is called the line of best fit. There's a whole lot of other math involved about why it goes where it does, but basically it makes it so that the distance between each point and the line is as small as possible. So it is the best linear estimate of the given data. And of course, the better our R value is, the closer it resembles an actual line. So this R value right here, I'd say it's probably about 0.75 or 0.8, because it's a nice, pretty line. You get to a point where you can kind of recognize it. I actually give like little pop quizzes to my high school students to recognize these, but we have a lot more time. I mean, the high school class is a whole year and we have 11 weeks. So we can't play as much. All right, let's do a least squared regression line. We're going to do it with the well depth. So we have that in our calculator. It should still be on your L1 and L2. I hope I didn't do something so that I can't use my calculator either. Nope, it's still good. Good. All right. We're going to just go, remember our well data is still in L1 and L2, just making sure it's there. It's in L1 and L2. So we're just going to go to stat, and we know mine's correct now. And we're going to go back to the same screen we were at before, to linreg AX plus B. And so I'm going to change this back to L1. So second one, change the second one back to L2, second 2, and go down to calculate and hit enter. Okay. So unfortunately, I can't write on this screen, but notice right here, y equals AX plus B. Does that look just a lot like our linear equation, y equals MX plus B? Isn't that kind of familiar? This is exactly y equals MX plus B. Texas Instruments just likes to mess us up and call this A. This A right here is your slope. This B right here is your y-intercept. So your equation is y equals this number right here times x plus this number right here. I'm going to write it on my screen so it's there when we get back to it. So y equals, and I just usually just round it to like 4 or something, or I just round it until I'm bored with writing. There's not any specific number that we care that you round it to. Just write until you're done. So our equation is y equals 0.01155x plus 5.527. This is our least squared regression line. So I'm going to go back to the other screen. So because our correlation coefficient was what, 0.77 or something like that. It's only moderately strong. So I'm not going to get a super great estimate. But if I wanted to estimate, let's say I wanted to estimate 105 feet. I wanted an estimate that's in here. Say I wanted 105 feet. I probably would get a decent estimate because it's right in the middle of our data. I could just take that 105 and plug it in for X, and I could probably get a pretty decent estimate. And I don't think that they're going to care all that much if it's super accurate. This isn't building the space shuttle. So 0.77 is probably okay. It's probably perfectly fine for them, because this, if I was a half a second off, nobody's going to die. Make sense? Questions so far? I have one slide left. You guys are awesome tonight. Okay, let's do one. Yeah,
I
go
don't
ahead.
know. My brain shut off, I think, I was trying to do the y equals and I wrote all my numbers down and everything, and then I lost what you said. I'm sorry. So I've got the 0.01155 x plus the 5.527, which is my A and my B.
Right. So this is y
what's the
equals, this is my
105?
slope, this is my x, this is my b,
Uh-huh.
so this is your slope. And this is the y-intercept. Whoops, I put that in a weird spot. Intercept. Because my correlation coefficient is just moderately strong, I'm not going to get a super accurate prediction if I'm making a prediction. It'll be decent, but it's not going to be super accurate. So like if I was going to predict 105, it might be okay. I could be a little bit off, but it's probably not going to kill anyone. It's probably not going to make it more dangerous, but it will be a decent estimate. And you would just plug 105 in for X and just solve, and that'll give you whatever Y value you need, just like we did back in Math 60 or whenever we did that. So this is just to make predictions. And generally, you don't have to do this. We write Y hat over it because anything with a hat is an estimate. But that's not super important. If you don't write Y hat, no one's going to be mad. But this is just a way to estimate our values because it is a somewhat accurate equation that matches our data. So let's do the same thing with the club head distance. So go ahead and try that. So use your L3 and your L4 if that's where you put it, and go ahead and see if you can get your least squared regression line. I'm going to give you a minute. I'm not going to do it right away.
While everybody's doing that, can you explain to me why my computer or my calculator, I should say, when I go to stats and I go to calc and I go down to linreg, or it doesn't give me the L1, L2, or L3, L4 options at all.
Okay, you have to put those in there. What do you mean it doesn't give you the options?
It does, it goes straight to the solution, to the problems, to the numbers. It doesn't give me any place to enter that in the calculator, and it says it's a TI-84. I don't know why it's not in there.
Okay, I don't know. Does it give you the same numbers I have?
It, when you start doing everything, it does. But then it doesn't give me the numbers when you go to the option, and I can enter stuff in L3 and L4, but it doesn't give me the option to change anything. So I guess I'll just use L1 and L2
Yeah.
with the calculator during the time.
Yeah, I would say just use L1 and L2 then, because I'm not sure without actually holding your calculator and playing with it. I don't know if I can.
Remember the code thing that you showed us in the very beginning?
The diagnostic?
I think, yeah, because mine only did that too, but when you showed me that part, then it did what yours does. So maybe, but I don't remember how you did it.
So try that. So you would do, so 1 second here. So you do second and then 0. And then just
Catalog down to diagnostics.
go to diagnostic on. I mean, we'll try it. I mean, if it can't hurt, right? And then you,
That's what we just did in the very beginning today, right?
right, did you do that with me?
I did it and it didn't work. It
Okay.
didn't.
So let's try this real quick. Click on mode.
Yeah, that,
Where's mode? Mode.
Mode
Oh.
is right next to second.
Okay.
Okay, so go down here. So stats wizard should be on and stats diagnostics should be on, these two things right here. So make sure both of those are on.
Oh, I don't even show that stuff.
You must, maybe you have an older TI 84 version. Can you scroll down more? Will it scroll down?
Uh-uh.
No?
It must be an older one. I bought it used online.
Yeah, it could be an older version, but just use L1 and L2 and you should be fine.
Okay, perfect. I'll do that then.
It's not that big of a deal. You should be okay.
Okay, perfect. Thank you.
Okay, so now I'm gonna do this while you all are, you're probably already there. You're probably already ahead of me now. But no, this is good. At least we're troubleshooting. Even if I can't help you, I will try. It's a tough thing about being online is I can't grab your calculator and play with it and try to fix it. Okay, and hit calculate. So we should have gotten this. And so I'm gonna write the equation that I have. So it would be y equals,
Velocity.
what was it?
When you do the equation, the y equals mx plus b,
Uh-huh.
what would you do with the x part?
That's just X.
Okay, so and then so you do a plus b and then equal it out.
So it's basically, on this one right here, I would have y equals 3.166x minus 55.797.
And that would
It's a
give you
negative.
the type of, and
Yes.
then it'd give you the type of slope
Yeah, so
that it is.
this is what I wrote down. This is a linear equation. I'm not sure what you're asking. So you got the equation,
Just,
right?
yeah, just what you do with the answer.
What do I do with the equation?
With like, so when you plug in the equation and you get the answer, what does the answer mean? Does that tell us what type of slope it is?
What do you mean by answer? I'm confused.
Well, don't you? I'm sorry. Don't you do the 3.166 minus 55?
No, this is it. This is your equation right here. This is my y equals mx plus b equation right here. It's 3.11166x minus 55.797. We're not doing any more math. This is it.
Well, that's it. Okay, I'm over here trying to plug in those numbers.
Yeah, don't do that. Don't
Okay,
do that.
sorry.
No. It's no,
Okay,
it's
thank
fine.
you.
Sorry, I didn't understand what you're saying. So what we would use this for, so this particular equation, so we had an R value of really high. What was it? 0.9387. So this is a pretty high one. So I still am not, I'm not going to go out to like predict, let's see, the Y is the, yes, the Y is the Y axis and the X is the X axis. Yes. So I'm not going to make a prediction that's like 200. I wouldn't want to go too far out, but I would feel comfortable making a prediction of 110, my X value of 110 or 115. I feel pretty comfortable with that because I have a strong correlation. So my predictions are going to be more accurate because my correlation coefficient is larger. It's closer to 1. So we just use this equation if we were going to make predictions. So that's all it's for. So if I want to make a prediction, I can grab an X value and plug it in for X and then solve to get the distance in yards. So I'm going to do one right now. I'm going to say, what if I wanted to estimate how far it would go if my club head speed was 110? Let's say that. I would do Y equals 3.166 times 10 times 110 minus 55.797. I'm just going to put that in my calculator and see what kind of a prediction I would get. And it gives me, my prediction is 292.463. So basically, this is saying that based on this equation, we would predict if the club head speed was about 110 miles per hour, the ball would go approximately 292 yards, sorry. So all we're doing is using this to make a prediction. Now, the further you go out away from the data you have, the worse your prediction's going to get because it isn't a perfect line, but you can go reasonably far out and make some predictions. That makes any sense at all. So all we're doing is creating an equation that we can use for predictions.
And why are we using minus on this one?
Because the
And
55
yet-
was negative. So if you take a look here, this is the B is a negative number. So because the B is negative, I made it its minus.
Okay,
All right. Nope. Good question though. All
not
right.
bad.
This is the end of the PowerPoint. So if anybody has any questions about the lesson part before we get to the lab, I am happy to answer those. Uh-oh, what the heck? I hate when I do that. My little cord, if it moves even slightly, shuts off the feed to my iPad, and it's annoying actually. And I have to play with it until I get it back. There it is. Okay. Set this down gently. All right. Any other questions before we get to the lab?
I think it's good.
Okay. All right, let's get, so we're on lab 3. So in the email that I sent out on Sunday, my normal Sunday email, I told you we need 2 variables we think might be associated. So, and they could be anything. I can't even think of, like, here, these are fictional characters that I have right here. I just took a husband's age. I took heterosexual couples, man and wife, ages of the man and the wife, and I'm seeing if those are correlated. It could be something like number of cups of coffee drank per day versus number of hours work per day. How many kids you have versus how many hours of sleep you get every night. I mean, it could be any 2 questions. It'd be 2 things on the same person. I really love sports ones because they're so easy. You could say like height of the basketball player in inches and how many points he scored last season. It could be just about anything. So just find your 2 variables you think are correlated. We need 20 each. So I think it says 50, but don't listen to it. Give me 20 each. And then put them in here, put your raw data in here. Please label your variables so that I know what your variables are. So once again, what is your population? My population would be Facebook friends, imaginary Facebook friends, but mine are Facebook friends. What variables are you studying? I am studying the ages, the correlation of the ages of husbands and wives, and I'm not interested in this at all. So it's just for fun. What are the units of my data? Age in years. So years would be my units. So on letter D, it says, why are you sure that your 2 variables have association? So this is more like your speculation. Why do you think they're correlated? I mean, if you're doing the cups of coffee and hours of sleep per night, say, or hours of work, say, I think people who work more probably drink more coffee. You're just making a guess here. Why do you think it's associated? And I just want, basically, I'm just looking for your why you think it is. It's just an opinion or just a thought. Why do you think so? How and where did you get your data? I pulled my Facebook friends. Here's the website URL. I mean, that all of this stuff is basically the same thing we've already been looking at. Let's create a scatter plot. So to create a scatter plot, I am going to highlight both of my variables, not the names of them, not the top. Actually, do I want those? No. I'm going to highlight my variables. I'm going to try with the names on the top and see if it makes a difference. It might. I don't know if it does or not. I don't usually do that. Then I'm going to insert. The cool thing is the recommended charts, if you have this, it will give you your scatter plot. Yeah, see, it doesn't give it to me the right anyway. but it'll give it to you. Or down here, you can see scatter plots. Just choose the basic scatter plot. Yeah, see it labeled the whole thing Wife's Age. I don't like that. I'm going to fix it in a minute. Okay, I'm going to stretch it out, make it nice and pretty. Okay, so before you start adding chart elements, choose something pretty that you want to do, whatever you want. If you want it to be black with little Mickey Mouse, they look like Mickey Mouses, or whatever you want it to look at, like figure that out first, because everything else disappears if you change it. So here we go. I'm just going to leave it like that. Now we're going to add chart elements. Up here in the top left, it says add chart element. I want lots of stuff. I want primary, horizontal and vertical axis titles. And I'm going to change this. Oops. I'm going to change this right here to age of spouses. You have to have a label. You have to have a label on your graph. And my X value is husband's age, because this is the first one, the one on the left, and my, come on, my vertical one. It's always hard to type in the vertical one, is wife's age. I can't spell wife apparently. Oh, it's because I put a Q in there. Wife's age. Okay, make sure you put labels on there. There's something else that we need to add now. Now, part of this is you need to add the trend line. So watch, to add chart element, add my trend line. I want linear. We are not doing anything other than linear, but click on more trend line options, because I want it to open up this right here. I want linear, but down here at the bottom, I want it to display the equation on the chart, and I want it to display the R squared value. I cannot make it display an R value, but it will give me R squared, and we can just take the square root of that. So linear, display equation, and display R squared. If you'd like, you can move this around. I'm going to move my equation. I didn't mean to move that. Fix that. I want to move my equation because I like it better over here, and I want to make it bigger. You do what you want to do to make things pretty. So I have my equation right there of the trend line, and I have my R squared value. So as we all know, when you take a square root, both the negative and the positive are answers, because a negative times a negative is a positive. So if I take the square root, I need to, in order to get my R value, I need to pay attention to, do I have a positive or negative slope? Mine is positive. I'm going to type in R value right here. Watch how Excel can take the square root for you. It equal SQR. This right here is square root. And then I'm just going to type in 0.8616 and enter, and it took that square root for me. My R value is pretty darn good. It's about 0.928. Mine is positive. So I have a strong positive linear relation here. So the correlation coefficient is strong and positive. So down here in F, you are going to talk about how good the association is between your two variables. I want you to reference your R value, and I want you to say whether it's positive or negative. Now, if yours has a negative association, you need to mention that your R value should be negative, because this is going to give you the positive answer right here when you calculate it. But if you notice your slope is negative, make sure you mention that when you're talking about the association of your variables. Right, that's it for the lab. Any questions?
My question would be, again, I don't understand why you would put the wife's on the vertical and the husband's on the horizontal,
Because
as opposed to doing
sorry.
it the other way. Good.
Because when, look over here. Because in my X and Y, remember X comes first. I have the husband first.
Oh, right, okay.
Yeah, that's the only
So it
reason.
depends on how we, okay,
Yeah. So whichever one is
Okay.
on the left is going to be your X value, whichever one's on the right is your Y value.
thank you, okay.
And that was a good question. Anybody else?
I had that same question, so I'm glad that she asked it.
This is why we ask questions in class. It's because most likely someone else has the same one. So anyone else have any questions?
So I have another one now.
Okay,
The R value, how did you get that again?
okay. So I
0.9.
just typed the words R value in here that I did square root. So I'm gonna, it won't let me make it bigger. So take a look up here. In my bar up here in the top, I type an equal
Okay.
SQRT. If you type in SQ, it's going to give you the option to click on RT. And then I just typed in that number, did parentheses, typed in my R squared value, and then just hit enter and it takes the square root for me.
Okay, remind me, where'd you get that?
The R value, R squared is right here on my chart, on my graph.
Oh, because it did it
Yes.
when you did the graph.
But it
Okay.
gives me R squared, and the R squared is not what I'm looking for. I'm looking for the R value. So not the R squared value. Just take the square root.
Is there a way to delete the R2 and put your R value in place of the R squared?
Unfortunately, there's not. It's really annoying, but it is what it is. I mean, the R squared does have a purpose, but I can even tell you what the R squared means. It means that 86.16% of our data. I'm sorry, I just got dust in my throat. 86.16% of our data can be explained by that linear equation. That's what it means, but we don't use that in this class. If you take 244, they will use R squared more. But in this class, we don't use R squared. We just use the R.
Okay, so do you just want us to keep at the bottom?
Yeah, or you can put it wherever you want.
Okay.
I mean, I don't care where you put it. This is just where I put it because I thought that that's a good spot for it. And it's right above where you're going to type other things. So it's easy to reference. Some people will put it up above their graph. They like it up there. They'll put it up here somewhere. So wherever, whatever you want to do with it. Anyone else?
Okay, so again, that was equal.
Yeah,
equal
okay.
to what?
I'm gonna, here, let me get real big here and I'm gonna redo it. Let me see if I can try to do it here. Okay, so equals SQRT. And once you start typing it in, it's gonna show up. So watch SQ, see how it just shows up right under here? You can click on that, or type in SQRT for square root and 0. I think it was 8616. I could be wrong. And then hit enter and it will give you your square root.
Okay, thank you.
I have a question. So if I were to do like number of hours worked per amount of caffeinated beverages,
Uh-huh.
even if it's like, okay, I see yours is kind of not in order either. It doesn't have to be in ascending order.
No, it doesn't have to at all. The Excel does all that magic for you.
Okay. Thank you.
You're welcome. Anyone else?
That's awesome.
Out of curiosity, Miss Kleiss,
Yes.
if you was to reverse the X and the Y's and had wife sage on bottom and husband on the side,
Uh-huh.
that would create a negative. Right.
It's gonna look almost exactly the same. Here, I can even do it for you. Hold on here. I'm gonna do some magic. I'm gonna copy this. Copy. And then paste. And I'm gonna get rid of this. Get rid of all this stuff here, and we're gonna create a new graph, and you will see. Okay, let's highlight this and insert scatter plot. It looks basically exactly the same.
That's pretty
Because
cool.
Yeah,
Mm,
as one's
I'm-
going up, so is the other.
My mind is telling me that because when you reverse them, that the age differences are reversed.
Well, yes,
It
but
tells me that the chart would be reversed.
as one thing is getting bigger, the other thing is also getting bigger. So as the husband's age gets bigger, the wife's age gets bigger. So that means as the wife's age gets bigger, so does the husband's age. So they're still both getting bigger.
Okay.
Would that do the same thing with the coffees or caffeinated beverages per day to how many hours worked?
Yeah, because the thing is, things like that, it's really hard to tell which is the explanatory and which is the response, because which thing is causing the other. Like the husbands and wife ages, whoops, I didn't mean to do that. One thing isn't causing the other, right? I mean, it's not, I mean, unless you think automatically, okay, so men want women that are close to their age. I don't know. I'm just making stuff up. But the one thing is not really causing the other. In a lot of things, there's not really a clear explanatory or a clear response. You're just looking for the relationship between two things. So it's not going to matter to me which one you have on the vertical and which you have on the horizontal. I don't really care. But basically, the one that I think causes the other is the one, or causes, I say causes, but the one that I think is in response to the other is usually the one I put as my Y, but it doesn't matter. All right. Any other questions? These are really great questions. Any others? All right. So I hope you all have a really fantastic
Yeah.
weekend.
I just got to make sure that the data doesn't play mind tricks, because
Oh,
it was
okay.
telling me if I reversed it that it would create a negative linear.
I'm sorry. I'm glad I was able to show you though, and kind of hopefully explain it. So I'll make sure to check my messages just in case anybody's playing mind tricks on you. Remember, Tuesday's class is just office hours drop in. Anybody's welcome, 5:30 to 6:30. I will be here just hanging out, waiting for people and ready to help with, obviously, I won't help you on the test itself, but if you have questions on the review, anything on the homework, or you just need me to give you assurance that you're going to do a great job, go ahead and pop in and I'll be here. And so the next new material will be Thursday next week.
And you're not doing class next week because of the test, right?
Yes, that on Tuesdays, because it was, I don't know, a few terms ago, somebody was saying that they really wished I had an office hours, and it's been really effective for a lot of people just to have that on the open day of the test, rather than giving you new material while you're in the middle of test taking time. And it just came up to be really stressful for people.
I appreciate that. I get so overwhelmed. So
And next week's material it does not take a ton of time, and there's not a lab. So it's not a big deal to put it all in one day.
Would you say that the questions on the review are preparing us for the test, or is there something that you would like to review with us before we go into the test?
I feel that between the homework assignments you've had, the examples in class, and the review, I feel like all of that does a pretty good job of preparing you for the test. I will say, be prepared to draw a box and whisker plot. I'm going to give you that. And I think I told you that in class though. Be prepared to draw a box and whisker plot, because you will be drawing one. So
is it based off of all of the materials, or just is it towards,
okay, well,
some-
so much of it. Well, the thing is because all the material builds on itself, I could ask you one question that covers 5 topics because we've built on it so much, like with the standard deviation and the mean and median and all of that. I mean, a lot of it really connects with each other. So, yeah. So I would not exclude anything.
we're just trying to get the more information out of you as we can.
Well, and I change the test every term, because if anybody repeats the class, I don't want them to have the same test. Plus, I don't want them to share things with other people. So I haven't finished writing it yet. I've started it, but I haven't finished it yet. So your guess is as good as mine what it'll end up looking like right now.
Oh, I was gonna ask you, you said the test is an hour and a half.
Uh-huh.
How many questions would that be?
Really hate that question. And nothing against you, but I don't even know how many questions. I don't pay attention to that. But some of them are multi-parted. So I could say, oh, there's 5 questions, but then you'll see it's 5 questions with 6 parts each, which it's not. But, so it's really hard question to answer because, I mean, it's usually, I don't know, I think 12 maybe. I don't know. It's hard to say. But things are multi-parted, so I don't really know.
Okay.
Are you gonna want us to print the test and write on it, or is it something that's
No,
done in like a math?
No, in fact, it's not printable. It's just directly it's in Delta Math. It's in Blackboard, and you'll write, show your work on a piece of paper and put your answers in the test. There are some questions that don't require any work. You don't have to write anything down for those. Like if I asked you, is this a statistic or a parameter? You don't have to write that down because all you're doing is just writing it.
And what if, I mean, I don't know if any of the, like, oh, enter in this or look at this data, this raw database and figure out Q1, Q3, mean, medium, like, what if we entered all that into our calculator? And could we just say the answers without showing our work since we use a calculator?
What I would like you to do in that case is say, like 1 var stats, write down what you used your calculator for. So if you use your data and you find, like, say I used my calculator to find the standard deviation, the mean, and the median and all of that, just like question 5, 1 var stats. So I know what you used, or 1 variable statistics, whatever calculator function you used.
Oh, okay. Okay.
And if you're calculating a z-score, show me the setup.
Okay.
So, all right. Anything else? All right, I'm going to stop the recording.